Have you ever imagined a giant deer with antlers so large it was almost unbelievable? Or a bird of prey the size of a small plane? The Ice Age, a harsh period but full of wonderful creatures. However, that grandeur is now only a faint trace. What made these monsters disappear from the earth? Let's go back in time to find out the tragic story of the ghosts of the Ice Age. During the icy Pleistocene, North America was home to a fearsome giant, the giant short-faced bear, genus Arctodus. They were truly monsters compared to modern bears, with the largest species, Arctodus simus, reaching up to 3 meters 10 feet tall when standing upright and weighing over a ton. Even the smaller species, Arctodus pristinus, dwarfed most bears today. A strange but powerful feature of theirs was their long, slender legs, which were more muscular than the typical bear build, suggesting an ability to run at incredible speed, perhaps to chase down large prey. As their name suggests, their snouts were shorter, giving them a distinctive, broad-nosed appearance. Their massive skulls contained powerful molars designed for tearing flesh, along with sharp, sturdy fangs capable of inflicting fatal wounds. The giant short-faced bear's incredibly powerful body structure, especially its shoulders and neck, allowed it to take down large prey during the Ice Age, a period in which it dominated from about 1.6 million years ago until its disappearance around 11,000 years ago, along with the extinction of many other megafauna. The diet of the giant short-faced bear remains a fascinating and controversial topic among scientists. Given its massive size and sharp teeth, there is no doubt that it was a carnivore. One popular theory is that it was a formidable hunter, using its long legs to achieve high speeds, chasing large prey such as bison, deer, and other mammals across North America. However, another view is that its enormous size may have given it an advantage in competition for food, making it an opportunistic scavenger, easily chasing smaller carnivores away from dead prey. Recent studies have even suggested a mixed diet, combining active hunting and scavenging. Regardless of its feeding method, the giant short-faced bear was adapted to live in a wide range of environments, from open grasslands to dense forests to rugged mountains across North America, from Alaska and Canada in the north to Mexico in the south, with particularly high fossil densities in the present-day United States. As for social life, current evidence is quite limited. But based on the behavior of modern bears, it is likely that the giant short-faced bear lived largely alone, only coming together during mating season and when females were raising cubs. The mystery of the giant short-faced bear's existence has been revealed by impressive fossil discoveries across North America. Scientists first learned of the existence of these extraordinary bears through the discovery of enormous fossilized bones and teeth, hardened remains preserved over tens of thousands of years, clearly demonstrating their enormous size. Intact fossil skulls also provide valuable information about the structure of the bear's heads, brain size, and incredible jaw strength. Although more rare, fossilized footprints have also been discovered, revealing the enormous size of their feet and hinting at the agility of a giant predator. These pieces of the past are preserved through the natural process of fossilization, as their bodies are gradually buried under layers of sediment, and over time, organic matter is replaced by minerals, forming stone statues of a bygone era. Natural forces, such as erosion and geological activity, also play an important role in excavating these remains, exposing fossil-bearing sedimentary layers to the surface. Paleontologists have actively conducted systematic excavations and research in areas with the potential to preserve traces of Ice Age animals. And more than once, it is the accidental discoveries of local people that have brought about surprising discoveries. Thanks to these tireless efforts, the image of the giant short-faced bear has gradually been recreated, allowing us to better understand its role as one of the apex predators in the harsh ecosystem of Ice Age North America. During the late Pleistocene, around 125,000 to 10,000 years ago, North and South America were home to a formidable hunting dog, the dire wolf. Although often portrayed as a monster wolf in popular culture, they were actually closely related to the gray wolf, Canis lupus, but had distinct characteristics. In size, the dire wolf was comparable to the largest modern gray wolves, with males of the dirus subspecies weighing an average of around 68 kilograms, 155 pounds, and the gildae subspecies around 60 kilograms, 130 pounds, with some individuals even larger. Notable differences were in their skulls and jaws. The dire wolf had a wider, more robust, and longer skull than the gray wolf, which could reach over 30 centimeters, 12 in. Their zygomatic arches were significantly expanded, and the sagittal crest, a ridge along the midline of the skull, was large, suggesting very powerful jaw muscles. The teeth and jaw structure indicate that the dire wolf's bite was significantly stronger than that of the gray wolf, perhaps the strongest of all canis species. Its canines had higher bending strength, and its maxillary teeth, the flesh-tearing teeth, were larger than those of modern gray wolves. In terms of build, the dire wolf had a more stocky and heavy frame than the gray wolf, suggesting that it focused more on power than speed, with shorter and more powerful legs in proportion. Another difference is that the dire wolf's feet were smaller than those of a gray wolf of similar body size. The dire wolf roamed the earth during the late Pleistocene and disappeared around 10,000 years ago during the Quaternary extinction event, along with many other large mammals. They were carnivores, preying on large Ice Age herbivores such as horses, ground sloths, mastodons, ancient bison, and camels. Isotope analysis suggests that horses may have been an important part of their diet. Evidence of broken teeth in many dire wolf fossils from the Rancho La Brea tar pit suggests that they may have also scavenged and competed for carcasses, perhaps even gnawed on bones, although they were not as specialized at this as hyenas. The large number of dire wolf fossils found together at sites such as Rancho La Brea suggests that they likely lived in packs, perhaps similar to the pack structure of modern gray wolves, consisting of a mated pair and their offspring. This pack-hunting lifestyle would have been very effective at bringing down large prey. Dire wolves inhabited a wide range of habitats across North and South America, including plains, grasslands, arid savannas, and some forested mountains, from sea level to elevations of 2,255 meters. Dire wolf fossils are found widely in North America, from southern Canada to Mexico, and less commonly in South America, with discoveries in Venezuela, Peru, and Bolivia. The La Brea tar pit in California is home to the largest concentration of dire wolf fossils, with the remains of over 3,600 individuals discovered. The existence of dire wolves has been revealed through numerous fossil discoveries, precious relics left over from the Ice Age. The fossilized bones and teeth, thanks to their hardness and excellent preservation, provide the most direct and clear evidence of the presence of this powerful hunting dog. The large size and muscular bone structure, along with the characteristic powerful teeth, are key signs that help scientists identify them. The fossilized skulls also provide detailed information about the structure of the head, brain size, and especially the developed jaw musculature, further strengthening the understanding of their incredible bite force. Although less common, fossilized footprints have also been found, revealing the size of the dire wolf's feet and perhaps how it moved. These pieces of the past are preserved by the natural process of fossilization when the carcasses are buried under layers of sediment, and over time, the organic matter is gradually replaced by minerals, forming durable fossils in stone. Natural processes such as erosion and geological activity also play an important role in exposing fossil-bearing sediments to the surface. Paleontologists have conducted systematic excavations and studies in areas where potential Ice Age fossils have been found, and the La Brea tar pit is a prime example of a site with a large concentration of dire wolf fossils. In addition, accidental discoveries by local people have contributed significantly to the knowledge of dire wolves. The first dire wolf fossils were found in the mid-19th century in Indiana. It is these diverse fossil discoveries that have allowed scientists to reconstruct images and better understand the role of the dire wolf in the Pleistocene ecosystem of the Americas. Imagine the Irish elk, a true giant of the deer world. At an impressive 2.1 meters at the shoulder for males, they rival the size of a modern moose. However, the most eye-catching feature is their massive antlers, the most magnificent and heaviest crown of any deer that has ever lived. The antlers are often shaped like a giant outstretched hand, with an incredible wingspan of up to 3.65 meters and a weight that can reach 40 kilograms. The variation in antler size and shape between individuals and populations further adds to the uniqueness of this species. In terms of body structure, they have many similarities with other deer species, possessing long, graceful legs suitable for sprinting. However, to be able to support and move with such huge antlers, the Irish elk must certainly possess an extremely developed and powerful neck and shoulder musculature. Although the exact color of their coat remains a mystery, scientists predict that they probably had a brown or gray coat, similar to other deer species that lived during the same period. These giant deer existed over a significant geological period from the late Pleistocene, about 400,000 years ago, to the early Holocene, about 7,700 years ago, with the last populations persisting in Siberia and possibly Ireland until very recently in Earth's history. Based on their tooth structure, Irish elk are believed to have been herbivorous, with a diet that probably included leaves, twigs, and other vegetation available in their habitat. They were adapted to live in a wide range of environments across their vast range, from open woodlands to open grasslands to perhaps even harsh, cold environments. Socially, it is thought that like many modern deer, male Irish elk were probably solitary or in small groups outside the breeding season. However, when the breeding season arrived, their enormous antlers became an important tool, used in displays of strength and fierce battles for the right to mate with females. The development of these impressive antlers would have required a considerable amount of energy, suggesting their importance in sexual selection and the maintenance of the species. Highly adaptable, Irish elk were once widely distributed across Eurasia, from Western Europe, including Ireland, Britain, France, Spain, across Central Europe, Eastern Europe, and as far as Siberia, with fossil remains found in both Central Asia and China, attesting to their success over a long geological period. The existence of the Irish elk is not a recent discovery of modern science, but has been known for centuries, as their huge and impressive antlers were frequently found in peat bogs, particularly in Ireland, where they are named. Initially, these strange antlers inspired stories of giant elk or even mythical creatures. However, as scientific understanding gradually developed in the 17th and 18th centuries, naturalists began to seriously study these remains and determined that they belonged to an extinct species of deer. Over time, not only antlers but also more complete skeletons were excavated, allowing scientists to reconstruct the size and overall anatomy of this giant deer. Paleontological excavations across Eurasia have yielded a wealth of fossils, including bones and teeth, that paint a more complete picture of their widespread distribution and evolution. In particular, the use of radiocarbon dating has allowed scientists to pinpoint the exact time frame in which the Irish elk once roamed the earth and when it disappeared. It is these constant and varied discoveries that have transformed the Irish elk from a mythical creature to a well-studied Ice Age animal, with its enormous antlers remaining a symbol of a bygone era. Moa is the common name for 9 extinct species of giant flightless birds endemic to New Zealand. They belong to the order Dinornithiformes and were the dominant herbivores in New Zealand's terrestrial ecosystem for millions of years. They are a testament to the miracle of evolution on an isolated island where birds abandoned the skies to rule the land. The size diversity of Moa is astonishing. From tiny individuals, the size of a large turkey, standing about 1.2 meters tall, to true giants such as the giant moa, Dinornis robustus and Dinornis novaezelandii, which reached 3.6 meters high, towering like mobile trees and weighing up to 230 kilograms. Their legs were powerful and muscular, not designed for gliding flight, but for steadying on the ground, traversing diverse terrain. The moa's long, graceful neck allowed it to easily reach the lush foliage that was its prized food source. Like its flightless cousins, the moa's sternum lacked the crucial bone that would have attached its flight muscles, a clear sign that it had completely given up on conquering the skies. To aid in the digestion of tough vegetation, the moa also had a secret weapon: stomach stones, gastroliths, which acted as internal millstones. This unique bird evolved and thrived in New Zealand for millions of years. from the distant Miocene through the Pliocene and Pleistocene, before facing a rapid extinction tragedy after humans arrived on the island around 1280 AD, and most of it disappeared from the face of the earth within a few centuries. Moas, the one-time inhabitants of New Zealand, were strictly herbivores, but showed remarkable diversity in their diets. Depending on the species and their habitat, they could specialize in consuming leaves, twigs, berries and seeds, and even trees and shrubs. The shape of their beaks reflected this variation, evolving to suit their preferred food sources. These remarkable adaptations allowed moas to inhabit a wide range of habitats across the New Zealand archipelago, from dense forests and scrublands to open grasslands and rugged mountains. Despite this, little is known about the social lives of moas. Some limited evidence suggests that they may have lived in small family groups, but social structures were probably not uniform across species. As for reproduction, the giant fossil eggs we have found show that moas laid large eggs, often singly, in rudimentary nests on the ground. However, the details of incubation and how they cared for their young remain a mystery that has yet to be fully resolved. The distribution of moas was also very diverse, with different species inhabiting different areas across the North, South, and Stewart Islands, demonstrating their remarkable ability to adapt to the different ecological conditions of New Zealand. Although the existence of moas was long known to the indigenous Maori of New Zealand, who coexisted with them until their eventual extinction, the discovery and scientific understanding of these giant birds was a long process. When Europeans arrived in New Zealand, they heard strange stories from the Maori about giant birds and found large skeletons that they believed belonged to mythical creatures. By the early 19th century, naturalists began to study these skeletons seriously and realized they belonged to extinct flightless birds that were completely different from any they had ever known. The turning point came in 1839, when the famous British anatomist, Sir Richard Owen, based on a single femur fragment, scientifically identified the moa, which he initially envisioned as a bird larger than an ostrich but smaller than an Andean condor. Over time, numerous fossilized remains of moas were discovered across New Zealand, including bones, complete skeletons, fossilized eggs, and even incredibly preserved soft tissue samples, such as feathers and muscles. These discoveries provided scientists with enough evidence to classify the different species of moa and reconstruct their appearance and better understand their biology. Systematic paleontological excavations at sites across New Zealand, from wet swamps to dark caves to coastal sand dunes, have yielded a rich treasure trove of moa fossils. In particular, advances in DNA analysis of ancient moa bones have opened up new insights into the evolutionary relationships between moa species, how they were classified, and the timing and causes of their tragic extinction. A giant bird of prey that lived in New Zealand. It had a wingspan of about 3 meters and could hunt moas. With its remarkable size, the female could weigh up to 18 kilograms and be up to 1.4 meters long. It was truly a monster bird of the late Pleistocene and early Holocene. Surprisingly, despite its massive body, its wingspan was relatively short, about 3 meters, a feature that was perfectly adapted for maneuvering flexibly among the dense trees and bushes where it hunted its prey. Its formidable weapon was its large, powerful, vulture-like beak, up to 130 millimeters long, capable of tearing the flesh and organs of its giant prey. Its legs were pillars of strength, thick and strong with sharp, large claws like those of a modern tiger, ensuring an inescapable grasp for any creature that dared to challenge it. With its muscular, stocky build, the Haast's eagle was the epitome of aerial prowess, a symbol of a time when it dominated the skies of New Zealand until its tragic disappearance some 500 to 600 years ago, following the arrival of humans and the decline of its main food source. The Haast's eagle was a formidable hunter, with a diet based largely on giant moas, large flightless birds that could weigh up to 230 kilograms, along with other large flightless birds of New Zealand. It is thought to have been an active predator, often swooping down from high perches to attack prey by surprise. An intriguing finding from a recent analysis in 2021 also suggests that after taking down its prey, it may have had a similar feeding strategy to that of a vulture, reaching deep into the body cavity to access nutrient-rich internal organs. The Haast's eagle's habitat, according to fossil evidence, was concentrated in the dense forests and scrublands of the South Island of New Zealand, where it probably hunted in these spaces and along open forest edges. Little is known about its social life, but, like many modern eagles, it was likely solitary for most of its life, only coming together during the breeding season to mate and raise its young. The range of this giant bird of prey was limited to the South Island of New Zealand, where it once ruled the skies before disappearing. When Europeans first arrived in New Zealand, they heard fantastic stories from the Maori about the giant Puakai raptor and occasionally found large, mysterious bones. It was not until 1872 that the bird was scientifically described by geologist and explorer Julius von Haast, who named it Aquila morai, later renamed Hieratus morai. Haast recognized it as a giant eagle, a fearsome predator of moas. Over time, numerous fossil remains, including bones, partial skeletons, and enormous talons, have been unearthed across the South Island, revealing its extraordinary size and anatomy. Morphological studies, comparing the bones of the Haast's eagle with those of other eagles, particularly the Australian lesser eagle, along with DNA analysis, have confirmed their close evolutionary relationship and shed light on the rapid size evolution of this magnificent bird of prey over a relatively short geological period. Want to learn something new every day? This channel is for you. Subscribe to get the latest tutorials and lessons.